Hello guys, and welcome to the GCE Math Panel, a team of certified experts and markers whose sole duty and objective is to provide you with past questions and answers in a format that is required and improve your grades. To get to us, you can email us on gcemathspanel@yahoo.com or gmail.com, and don't forget to subscribe, to click, to like, to share your comments with us. You can equally send us a WhatsApp message. Let us begin with the first question of this June 2019 paper 2 765/775 mathematics advanced level. The polynomial p of x is such that p of x is equal to ax cubed minus 3x squared plus bx plus 6. Given that x plus 2 is a factor of p of x and that p of x is divided by x minus 1, the remainder is minus 6, find the values of a and b. So according to this question, if x plus 2 is a factor, then it implies that equating x plus 2 to 0 gives us x equals minus 2 and p of minus 2 is equal to 0 since x plus 2 is a factor. And substituting the value of minus 2 in the equation, we'll have a into minus 2 to the power 3 minus 3 into minus 2 squared minus 2 times b plus 6, that is equal to 0 according to the condition for being a factor. And this implies minus 8a minus 12 minus 2b is plus 6 should be equal to 0. Simplifying this equation gives us minus 4a minus b equals 3, equation 1. Now the second condition for this equation states that when this polynomial is divided by x minus 1, the remainder is minus 6. And this therefore means that p of 1 should be equal to minus 6. And substituting 1 into the equation equally gives us a into 1 to the power 3 minus 3 into 1 to the power 2 plus b into 1 plus 6 is equal to 0. And when we simplify, we have a plus b equals minus 9, giving us equation 2. Adding the two equations gives us minus 3a is equals minus 6, and dividing all through by minus 3 gives us a to be 2, and substituting the value of a equals 2 in one of the equations gives us b to be minus 9 minus 2, which is equals minus 11. So this gives us method 2 marks, accuracy 2 marks. Now the b part of the equation states, hence solve the equation p of x equals 0. We already know that x plus 2 is a factor. So to solve the equation p of x equals 0, we just have to do long division. So we have x minus 2 and the polynomial 2x cubed minus 3x squared minus 11x plus 6 divided by this factor. And we have 2x cubed divided by x gives us 2x squared. Now 2x squared times x gives us 2x cubed. 2x squared times plus 2 gives us 4x squared. When we subtract, we will have minus 7x squared. We bring down the other terms, minus 11x plus 6. Now minus 7x squared divided by x gives us minus 7x, and minus 7x times x gives us minus 7x squared. Minus 7x times 2 gives us minus 14x. When you subtract, we will have 3x plus 6. Now 3x divided by x gives us plus 3, and 3 times x gives us 3x, plus 3 times plus 2 gives us plus 6, and when you subtract, we find out that there is 0. This only happens when we divide by a factor. When you divide by a factor, the final remainder will be 0. Therefore, this function can now be written as 2x squared minus 7x plus 3 times x plus 2 equals 0. And we can factorize this quadratic equation where we have 2x squared minus 7x plus 3 can be written as the two numbers that when we multiply, we will have 6, and when we add, we have minus 7. We have minus 6x and minus x. So we put in that equation, we group. For the first group, we have the common factor to be 2x. 2x squared divided by 2x gives us x, and minus 6x divided by 2x gives us minus 3. For the second group, first of all, bring down the sign minus. Now minus x divided by the minus there gives us 1, and we have x into 1 into x minus 3. So now finally factorizing, we have x minus 3 into 2x minus 1. We now replace this quadratic by these values here, and equate to 0. At this point, each of these factors should be equal to 0. So we have x minus 3 equals 0, or 2x minus 1 equals 0, or x plus 2 equals 0, giving us x equals 3, or x equals a half, or x equals minus 2. So method 3, accuracy 1. This brings us to the C part of the equation, which states that two statements P and Q are given by P. Comfort studies hard, and Q, she will pass the examination. Write out the following propositions in ordinary English. So the first one is an implication. We have P implies Q. This is an implication and is read as, if Comfort studies hard, she will pass the examination, 1 mark. The second one we have, the negation of P implies negation of Q. Actually, this is the inverse of a logic statement. So it is read as, if Comfort does not study hard, she will not pass the examination. We have the negation of an implication. When you simplify the negation of an implication using De Morgan's rules, we have P and not Q. And in this case, we can equally note that an implication can equally be written as not P or Q. Let us simplify what we have here. So this will be read as, Comfort studies hard and she will not pass the examination. Sometimes they may say, but she will not pass the examination. Comfort studies hard and she will not pass the examination because of the logic and that is found there. This brings us to question 2. Two variables x and y are related by an equation of the form y equals log 10 log mx plus c, the base there is 10. And we are given the values on the table as shown. A. Draw a linear graph by plotting values of 10 to the power y versus x. So the question here is clear. We are supposed to use the values of 10 to the power y and plot against x. So we first of all write this equation in a form that is suitable for us to work with. So we rearrange in index form and we will have 10 to the power y is equal to mx plus c. Now we make a table of values for 10 to the power y and x. So the table has been given to us. Each of the y values, we raise 10 to each of the y values. So the first value we have 10 to the power 0.857 giving us 7.2. Second one 10 to the power 0.924 giving us 8.4. Same with the third 9.6, 10.8, 12.0 and 13.2. Now let's use a very good scale. Here I have chosen to use a scale of 2 centimeters to represent 1 unit on both axes. Now let us do the plotting. Remember that we are plotting the values of x versus 10 to the power y. So when x is 1, we have y to be 7.2, that's 10 to the power y. The next value is 2 and 8.4. We have 3 and 9.6, 4 and 10.8, 5 and 12.0, and 6 and 13.2. We now link this point with the straight edge of our ruler giving us that line. And we can look for the gradient by using a large triangle. Using the 2 points where it cuts, we have A 5.5, 12.5, and at B 1.3, 7.5. So the change in these values, before getting to that, the y-intercept here is given as 6. That is the point where the graph cuts the y-axis. So the value of C is 6. And the change in y is 5.0. The change in x is 4.2. So you can get the gradient as change in y on change in x, which equals 5.0 and 4.2 equals 1.2. But the question states that we should give our answers to the nearest whole number. So 1.2, the nearest whole number is 1, and 6 is already a whole number. So these are the values that we have. Method 5, accuracy 3. The B part of the question has been answered as well. We now move to question number 3. The A part of the question reads, a function is defined by f is such that x is mapped onto 2x plus 1 on x minus 4, where x is an element of R and x is not equal to 4. A. Show that f is injective. Injectivity means one-to-one. For a function to be injective, it has to be a one-to-one function. So f is injective if for every x and y an element of the set of real numbers, f of x equals f of y implies x equals y. This is used in test. So let us look at x, f of y equals f of x, and that gives us what we have on the screen. So cross multiplying, we have 2y plus 1 on y minus 4 equals 2x plus 1 on x minus 4. and that will give us x minus 4 times 2y plus 1 to be equal to y minus 4 times 2x plus 1. When you open out the brackets, we have 2xy plus x minus 8y minus 4 to be equal to 2xy plus y minus 8xy minus 4. This 2xy cancels out on both sides as well as minus 4, and we are left with 9x is equal to 9y, and you cancel out, you have x to be equal to y. Therefore, the function is injective. It is one-to-one. So the A part is cleared. Now B, find the inverse of the function and state its domain. So to find the inverse of the function, you just have to replace f of x by y and solve for x. So we have y to be equal to 2x plus 1 on x minus 4. We cross multiply, we have y into x minus 4 equals 2x plus 1. Opening out the brackets, we have xy minus 4y is equals to x plus 1. Bringing like terms together, we have xy minus 2x equals 4y plus 1. And factorizing, we will have x into y minus 2 equals 4y plus 1. And x will be equal to 4y plus 1 divided by y on y minus 2. We now replace x by inverse function f inverse of x and replace y by x. That gives us 4x plus 1 on x minus 2. The equation states that we should equally give the domain. So this function is defined if the denominator is not equal to 0. And this denominator will only be equal to 0 if x equals 2. So the domain is a set of all real numbers excluding x equals 2. So it has been defined. You can write it out as what was given in the equation, x is an element of R where x is not equal to 2. That will equally be the same. Method 3, accuracy 3. Now the next part of the equation, a relation R is defined on the set of integers by A relates to A implies A plus B is equal to 2m plus 1, where m is an integer. That's the relation A to B. Show that R is an equivalent relation. According to work that we have done in lower set, you know that a relation is said to be an equivalent relation if it is reflexive, symmetric, and transitive. It has to be reflexive, symmetric, and transitive. If one of these conditions fails, then you conclude that it's not an equivalent relation. There is no need to progress. Let us start with the first one, reflexivity. So we have, suppose A is an element of Z, then we have A relates to A implies A plus A equals 2A. And 2A actually in the set of integers is an even number. However, our relation here states that A relates to B is an odd number. So it therefore means that from this first step, the relation R is not reflexive, and there is no need for us to waste our time looking at the other properties. We just have to conclude that it is not an equivalent relation since this first property has failed. Alright, question number 4, you are given the function k plus 5x squared minus 10x plus 2kx equals 9k is a quadratic equation. Find the values of the constant k for which the roots are equal. You have to note that you first of all have to arrange this equation in the general form, because if you look at it critically, you see that it's not in the general form. So the roots of the equation are normally supposed to be equal to, that's the discriminant is supposed to be equal to 0 if the roots are supposed to be equal. In this case, we have the discriminant to be equal to 0, where the discriminant is defined as d equals b squared minus 4ac. And writing this equation in the general form, we have k plus 5, all of that, x squared plus x into minus 10 plus 2k is minus 9k equals 0. We can now look for the discriminant and equate to 0. That gives us our b squared minus 4 times a times c equals 0. When you open out, you have 100 minus 40k plus 4k squared plus 36k squared plus 180k equals 0. Bringing like terms together, we have 40k squared plus 140k plus 100 equals 0. You can divide all through by 20 and you will have 2k squared plus 7k plus 5 equals 0. And factorizing this equation, you have k plus 1 into 2k plus 5 is equal to 0, and k will be equal to 1, or k equals minus 5 on 2. So those are the values of k if the roots of this equation are supposed to be real and equal. Alright, that brings us to the second part of the equation, which states that there are 6 girls and 4 boys in a class. 3 students are to be chosen at random so as to be awarded a scholarship. In how many ways can this be done if at least 1 boy and 1 girl must be in the selection? So in this selection, we first of all have to look for the number of ways to select girls and number of ways to select boys. However, this selection consists of 3 members. 3 people are to be chosen. You can either have 2 girls and 1 boy or 1 boy and 2 girls. So that's the first thing we have. The first selection, let's say we have 2 girls and 1 boy, on the second, or actually means plus or addition, 1 girl and 2 boys. So if you have to select 2 girls from 6 girls, you have 6 combination 2 and 1 boy. So times selecting 1 boy from 4 boys is 4 combination 1. Now we bring the or. The or here stands for addition. The other way to do it, we either do the selection this way or we do it 1 girl and 2 boys. So selecting 1 girl from 6 girls is 6 combination 1, and selecting 2 boys from 4 boys is 4 combination 2. We can now open our brackets and simplify. 6 combination 2 is the same as 6 factorial on 4 factorial 2 factorial. So that's the same as 6 times 5 times 4 factorial on 4 factorial 2 factorial. 4 combination 1 is the same as 4 times 3 factorial on 3 factorial 1 factorial. 6 combination 1 is 6 times 5 factorial on 5 factorial 1 factorial. And the last one is 4 times 3 times 2 factorial on 2 factorial 2 factorial. And then we have the positive sign in between. When we cancel out, we'll be left with 15, 4, 6, and 6. So we have 15 times 4, which gives us 60, and 6 times 6, which gives us 36, and a total of 96 ways. So method 2, accuracy 1. That brings us to question 5. We are given the function x cubed minus 4x squared minus x minus 12 to verify that f of x equals 0 has a root in the interval 4 and 5. Alright, so here we have f of x to be equal to that. F of x will have a root in this interval if f of 4 times f of 5 is less than 0. This less than 0 indicates that it has crossed the line. So let us look for f of 4. F of 4 gives us minus 16 and f of 5 gives us 8. So f of 4 times f of 5 will be equal to minus 16 times 8, which gives us minus 128, and this number is less than 0. Therefore, there is a root between 4 and 5. That is our conclusion. Okay, now the second part of the equation says that taking 4.5 as the first approximate root of this equation, f of x equals 0, use the Newton-Raphson procedure to find a second approximation to the root of the equation, giving your answer to 2 decimal places. So according to the Newton-Raphson is given us, since the first root is x0, the second root is x1. So x1 will be equal to the first root minus f of the first root over f prime of that first root. And our x0 here is 4.5, and f of x is equal to that function. So f of x0 will be equal to 4.5 into this function. When you substitute 4.5, you have minus 6.375. Now f prime of x, when you differentiate this function, you have 3x squared minus 8x minus 1. When you substitute our x0 inside, that gives us 23.75. So our second approximation will be 4.5 minus 6.375 on 23.75, and when you simplify, we have 4.77, and we have to give our answer to 2 decimal places. That gives us 4.77 as stated earlier. So 4 marks for method and 3 marks for accuracy altogether. Let's move on to the next part of the question. So the sum of the first n terms of a sequence is defined as Sn equals 2n squared plus n. Find the 10th term of this sequence. So Sn here stands for the sum of the first n terms, not the nth term. So if you are to look for the 10th term, the 10th term using sum can be given as the sum of the first 10 terms minus the sum of the first 9 terms. So my St10 will be given by S10 minus S9. and the sum of the first 10 terms is 2 into 10 squared plus 10 minus 2 into 9 squared minus 9. When you simplify this, you have 39. So my 10th term is 39. Recall, the 10th term is S10 minus S9. Now the next part says that the nth term of this sequence. The nth term means the general formula to obtain any of the terms. For me to obtain the nth term using the sum, I'll use the same procedure I've used in A. So the nth term will be given by Sn minus Sn minus 1. So let us look for Sn minus 1. Sn minus 1 gives us 2 into, I replace n by n minus 1 squared plus n minus 1. Opening out the brackets, we have 2n squared minus 4n plus 2 plus n minus 1. And when we simplify, we have 2n squared minus 3n plus 1. We now look for Tn. Our Tn is Sn minus Sn minus 1, and as I said earlier, and this will give us 2n squared plus n minus, recall, you have to use the brackets because negative signs are involved here. Without the bracket, it's mathematically wrong. Minus 2n squared minus 3n plus 1. So when you cancel out the 2n squares, we'll be left with 4n minus 1. So that's our nth term. You can even test it to answer the A part of sub 2. If you put the value of 10 in that 4n minus 1, you have 40 minus 1, which gives us 39, which therefore means that there is a 100% correlation with this formula and what was used in A. That brings us to question number 6. Recall, if you have to get to us, you have to first of all subscribe, click like, share your comments with us, and then you can send us a mail on gcemathspanel@yahoo.com or gmail.com, or you can send us a WhatsApp message. It's good that these messages go across so that other people may equally improve their grades. That brings us to the next question. Question number 6. Solve the differential equation x squared minus 1 divided by x plus 2y is equals 0. Given that y equals 3 when x equals 2. Express your answer in the form y equals f of x. So looking at this differential equation, you find out that we can easily solve it by separating variables, and in this case we have x squared minus 1 dy is equal to minus 2y dx, and separating variables we have dy on minus 2y equals dx on x squared minus 1. But the right hand side can be expressed in partial fraction as 1 over x squared minus 1 to be identical to a over x minus 1 plus b over x plus 1. And simplifying this, we have 1 to be identical to a into x plus 1 plus b into x minus 1. A plus b, that's equating coefficients. A plus b will be equal to 0 and a minus b will be equal to 1. So in this case, we have a to be a half and b to be minus a half. We now put into our equation, we have 1 over x squared minus 1 to be equal to a half on x minus 1 minus a half on x plus 1. So we can now move on to our integration. Integrating both sides, left hand side will have the integral of a half dy on y should be equal to right hand side a half dx on x minus 1 minus a half dx on x plus 1. So left hand side will give us a half ln absolute y is equal to a half ln absolute x minus a half ln absolute x plus 1. And you see that 2 is common, so I have minus ln y multiplying all through by 2 is equal to ln x minus 1 on x plus y when you simplify plus 2 times the constant. And when the equation tells us that when x is equal to 3, x is equal to 2, they want us to use these values to solve and obtain the value of c. So we fit in these values into our integral. We have minus ln 3 is equal to ln x minus 2 minus 1, which is 1, over 2 plus 1, which is 3. And this gives us c to be equal to 0. So our c is 0. So our equation can now be written as 1 on y is equal to x minus 1 all over x plus 1. Now the question is, why the 1 on y? Remember that minus ln y is the same as ln 1 over y. And since the both sides have ln, I can remove the ln and I'll be left with 1 over y is equal to x minus 1 over x plus 1. But the question equally says I should give my answer in the form y equals f of x. So when you cross multiply, you will have y to be equal to x plus 1 over x minus 1. Okay. Now the next part of the equation reads, you are given the function f of x equals 2x plus 1 over x minus 4. Sketch the graph of y equals f of x, showing clearly all the intercepts and the behavior of the curve as it approaches its asymptotes. 6 marks. So we have to sketch f of x and show the intercepts and the behavior of the curve as it approaches its asymptotes. So let us look at this equation. So the first thing is for us to get the domain. We start by equating the denominator to 0. So you have x minus 4 equals 0, implies x equals 4. So the domain of this function is a set of all real numbers excluding x equals 4. And writing it in interval notation, we have from negative infinity to 4 union, from 4 from above to positive infinity. The next thing is to look for the limit at these different boundaries. According to the domain, there are 4 boundaries. You have negative infinity and positive infinity. So the limit at negative infinity, just divide the highest in the numerator by highest in the denominator, and that gives us 2. So you find out that the limit at positive infinity and the limit at negative infinity are both 2. So I can combine the limits and write the limit of f as it tends to positive or negative infinity, and that gives us 2. Now the limit as x tends to 4 from below. Let us take any number very close to 4, not far from 4. I'll take 3.9. So 2 into 3.9 plus 1 over 3.9 minus 1, that gives us a negative number. And my answer is negative infinity. Why negative infinity? Because when you are taking the limit at an asymptote, that's a vertical asymptote, your answer is always equal to infinity. And according to the domain of definition, 4 is a vertical asymptote. So using these numbers just helps to guide me. If I have a negative value, it means that my answer is negative infinity. If I have a positive value, it means it is positive infinity. Now let's take the limit of as x tends to 4 from above. From above, we can take 4.1. So that gives us 2 into 4.1 plus 1. All of that gives us a positive value. So the limit is positive infinity because it is at an asymptote as well. Now, so the vertical asymptote from the domain of definition is 4, and the limit as x tends to positive or negative infinity gives us 2, meaning that the horizontal asymptote is the line y equals 2. It therefore means we can equally write down the center of symmetry. The center of symmetry comprises of the vertical asymptotes and the horizontal asymptotes as its coordinates. So that gives us omega having coordinates 4, 2. And the next thing now is to look for the intercepts. The question stated that we should get the intercepts. So when x is equal to 0, we put 0 into this equation, y will be minus 1 on 4. So our first intercept is the point A, 0 minus 1/4. Then when y equals 0, on the other hand, x will be minus a half. So our second intercept is when x is minus a half and y is 0. We can now look for the gradient function f prime of x. So in this case, we have from what you had in lower seat, bottom constant is differentiate the top, bottom constant x minus 4, differentiate top, you have 2, minus top constant 2x plus 1, differentiate bottom, you have 1, all that on bottom squared, all that on x minus 4 squared. When we simplify, we have minus 9 all over x minus 4 squared. Since there is no variable in the numerator, it means this function has no turning point. And looking at the function, the denominator is always positive. Since the numerator is negative, it means this function is always negative, and therefore the function is always decreasing. So there is no turning point, and the function f is strictly decreasing. We can equally make a variation table to make this clear. So the variation table for the x, the domain of definition gives us negative infinity. We have an asymptote at 4, then we have positive infinity. Since the function is always decreasing, as already stated, so in all the intervals you have minus, minus. So now, when x is at negative infinity and it decreases, at negative infinity, f of negative infinity gives us 2, that is the limit. Then it decreases to when x is 4, that's to negative infinity. Then 4 from above, we have positive infinity decreasing to when x tends to negative infinity to positive infinity, now we have 2. So that's the variation table, and we can now move on to sketch this curve on a Cartesian plane. So we have the vertical asymptote, the line x equals 4, and the horizontal asymptote, the line y equals 2. These are the two lines. We can plot, that's the first intercept. When x is equal to 0, y is minus 1/4, and when x equals minus a half, y equals 0. We have those two intercepts, we have indicated them. Our curve now passes through those 2 points, and that's the other part of it. So this is the curve of the function f of x equals 2x plus 1 on x minus 4. Okay, so it is complete and everything has been indicated. Let us go ahead. We have question 7. The vector equations of two lines L1 and L2 are given by those equations that and that, where alpha, lambda, and mu are constants. Given that the lines L1 and L2 intersect, find the values of A of alpha at the point of intersection. So if the two lines intersect, you just have to equate the two lines at the point of intersection. L1 must be equal to L2. So we have in matrix form, we have 1 minus 1 3 plus lambda into 1 minus 1 1 should be equal to 2 alpha 6 plus mu into 2 1 3. Equating coefficients, we obtain that system of equations, and equation 1 implies lambda is equal to 1 plus 2 mu. When you substitute this value into equation 3, we will have 3 plus 1 plus 2 mu to be equal to 6 mu, and mu will be equal to minus 2. Now lambda will be equal to 1 plus 2 into minus 2, which is equal to minus 3. And when we substitute, we obtain our alpha to be equal to 4 as requested in the equation. Now the B part states that the position vector at the point of intersection. So the position vector at the point of intersection, you just have to use one of the lines. You can use line 1 or you can use line 2, and you put in the value of alpha in line 1, or you move to line 2 and put in the values of alpha and mu. So in this case, I would just like to use the first line. So we have 1 minus 1 3 plus the value of lambda is minus 3, we put into the equation, and when we simplify, you have minus 2 2 0. So that's the position vector at the point of intersection. Now C states that you find the cosine of the acute angle between the lines 1 and 2. So to find the cosine of the acute angle between the lines 1 and 2, we know that cos theta is equal to A dot B on absolute A, absolute B. And to get the cosine of the angle between the two lines, we have to use their direction vectors. You have to use the direction vectors. The first vector, the direction vector is 1 minus 1 1, and with the second, you have 2 1 3. So A dot B gives us 1 minus 1 plus 1 minus 1 1, then times 2 1 3, all over absolute of A times absolute of B. When we simplify, we have 4 all on root 3 root 14, and that gives us 4 over root 42. So that is the cosine of the acute angle between the lines 1 and 2. That's a mark allocation. And the next question, question 8, reads the function f is defined as f of x equals 2 on x squared minus 1. Express f of x in partial fractions. So in partial fractions, you have 2 all over x squared minus 1 to be identical to a all over x minus 1 plus b over x plus 1, and 2 will be equal to or identical to a into x plus 1 plus b into x minus 1. And this gives us equating coefficients. We will have a plus b equals 0 and a minus b equals 2. Thus, a is 1 and b is minus 1. So when we substitute these values into the function, we have 1 over x minus 1 minus 1 over x plus 1. We have expressed in partial fractions. B, hence, show that the integral from 3 to 5 of f of x dx is equal to ln 4. So we just have to integrate this function from 3 to 5, and that gives us, integrating, we have ln x minus 1 minus ln x plus 1 from 3 to 5. We put in the values from 3 to 5. You have ln 5 minus 1 on 5 plus 1 minus ln 3 minus 1 on 3 plus 1. This gives us ln 2/3 minus ln 1/2. And following the second law of logarithms, you just have to divide. That gives us 2 on 3 times 2 on 1. That is multiplied by the reciprocal, and that gives us ln 4 on 3 as required. Method 4, accuracy 2. The second part of question 8 states that find the integral of cos cubed x sin cubed x dx. So cos cubed x sin cubed x, we can express it as sin cubed x cos squared x cos x. We break down the cos x into cos squared x cos x, and this will give us sine cubed x into 1 minus sine squared x cos x. So simplifying, we have further, we have sine cubed x minus sine to the power 5x cos x. Now let IU be equal to sine x. That will give us du to be equal to cos x dx. So putting into the function, the integral function, we have sine cubed x minus sine to the power 5x cos x dx. Integrating the first part, or replacing it by its value, you have, since u is equal to sine x, then sine cubed x will be equal to u cubed, and sine to the power 5x will be equal to u to the power 5. And from our work, cos x dx is equal to du. So integrating this, we have u to the power 4 on 4 minus u to the power 6 on 6 plus the constant of integration. Now replacing this by the different values, we now have sine to the power 4x on 4 minus sine to the power 6x on 6 plus the new constant. Now since you have replaced the value, the constant has to actually change, or c prime, where c prime is an element of the set of real numbers. So this is the integral of this function. Method 2, accuracy 2. And now question 9. Given that f of theta is equal to sine theta minus root 3 cos theta, express f of theta in the form r sine theta minus lambda, where r is positive and lambda lies between 0 and pi on 2. So f of theta is equal to sine theta minus root 3 cos theta is identical to r sine theta cos lambda minus cos theta sine lambda. So when we open out the brackets with this one, or equating coefficients, we have r cos lambda to be 1 and r sine lambda to be equal to root 3. So r sine lambda squared plus r cos lambda squared should be equal to root 3 squared plus 1 squared. That's squaring both sides and adding them. And this gives us r squared sine squared lambda plus cos squared lambda to be equal to root 3 squared is 3 plus 1 squared, that gives us 4. So sine squared lambda plus cos squared lambda is 1 times r squared is r squared, giving us 4. So r will be equal to 2. Recall that r has to be positive. So r sine lambda should be equal to root 3 and r cos lambda is equal to 1. So we divide r sine lambda by r cos lambda and we obtain tan lambda to be equal to root 3. And lambda will be equal to arc tan root 3, giving us pi on 3. So f of theta now will be equal to 2 sine theta minus pi on 3. The B part says that we should now find the maximum and minimum values of 1 over f of theta plus 3. So we'll start by first of all working with f of theta. Our f of theta here is 2 sine theta minus pi on 3. Note that the first thing to write down here is sine theta lies between minus 1 and plus 1. So sine theta minus pi on 3 will lie between minus 1 and plus 1. The next thing now here is to multiply by 2. So minus 2 will lie between minus 2 times sine theta minus pi on 3 less than or equal to 2. Then the next thing, we add 3 to both sides of the equation, so that we are trying to come out with the function that's been given in the equation. And this will give us 1 to be less than or equal to 2 sine theta minus pi on 3 plus 3, all over less than or equal to 5 rather. And now we have 1 to be less than or equal to f of theta plus 3 less than or equal to 5. You can see our f of theta actually coming out clear. Now we look at the extremes. The extremes here we have 1 and 5. So 1 over 1 will give us 1. 1 over f of theta plus 3 should be greater than or equal to 1 on 5. Now, since we are taking the reciprocal of everything, the inequality signs we equally have to reverse, because know that 1 is normally greater than 1/5. So the inequality signs reverse, and the maximum value of this function will now be 1, and the minimum value is 1/5. You can see the extremes. The other extreme is at 1 and the other extreme is at 1/5. So the maximum value of the function is 1 and the minimum value is 1/5. The second part of question 9, we have find the intervals for which the function h of x equals x cubed minus 3x is strictly a increasing and b decreasing. So you have first of all have to study this function from its domain and the limits as well as the turning points. So the domain of this function is from negative infinity to positive infinity. Recall that this is a polynomial function, so the domain is a set of all real numbers. Now the differential of the function, or f prime, is equal to 3x squared minus 3. And when we solve for x here, we will have x is equal to 1 or x equals minus 1. So we now look for f prime of x at x less than minus 1. So we put any value of x which is less than minus 1. You can even put 0. We put x less than minus 1. There we have the function will be positive. We look for f prime at x greater than minus 1. It is negative. So this indicates that this particular point is actually a maximum turning point, because from positive to negative indicates a maximum turning point. But that's not our interest actually. So f prime of x at x less than 1 is negative as well when you test, and at x greater than 1 is positive when you test. And I've shown you how to test in the previous question. So thus, according to this function, we have the values negative infinity, we have minus 1, we have 1, and we have positive infinity. So we want to look for the interval which is increasing. So according to what we have studied so far, in the interval from negative infinity to 1, from negative infinity to negative 1, we saw that the function is increasing from the first f prime of x at x less than negative 1, which is positive. So it increases in that interval and equally increases again from x strictly greater than 1. At the turning point, we don't consider them because the turning point is not strictly, the strictly is not inside the turning point. So we are not including them because it's neither increasing nor decreasing at the turning point. You cannot really define it, though it's not a point of inflection equally. So in the interval minus infinity to 1 from below and positive 1 from above to positive infinity, the function is increasing. Then for the decreasing interval, we have from minus 1 to positive 1, the function is actually decreasing. So these are the intervals where the function is increasing and when it is decreasing. That brings us to question 10. And to get to us, don't forget to subscribe, to watch, to share your comments with us, and you can send us a mail at gcemathspanel@yahoo.com or gmail.com, or send us a WhatsApp message in case of any query, and we'll get to you in no time. So this brings us to the last question for June 2019, paper 2, 770 and 765. So given z equals 1 minus I root 3, express z in the form r cos theta plus I sin theta. So z is equal to 1 minus I root 3. R cos theta plus I sin theta is identical to 1 minus I root 3. So r cos theta equating coefficients will be 1, and r sin theta will be equal to root minus root 3. So r will be equal to 1 squared plus minus root 3 squared. The square root of all of that gives us 2. And our tan theta will be equal to r sin theta over r cos theta, and that gives us minus root 3. So theta is arc tan minus root 3, gives us minus pi on 3. So as z is equal to 2 cos minus pi on 3 plus I sin minus pi on 3. So z equals 2 cos pi on 3 minus I sin pi on 3. Recall that the cosine function is an even function. So cos minus pi on 3 is the same as cos pi on 3. That's why we have replaced minus pi on 3 with the cosine function as pi on 3. And the sine function is an odd function. So sine minus pi on 3 is the same as minus sine pi on 3. And that's why it has been written in this form. So as z now becomes, the second part of the equation says if you express z to the power 7 in the form re to the I theta, that is exponential form. Here we just have to raise both sides to the power 7. That gives us z to the power 7 equals 2 to the power 7 times e to the I pi on 3 to the power 7. That gives us e to the minus I 7 on 3 pi. And when you express 2 to the power 7, it gives us 128. So this is this function in exponential form. Now question 10, the second part. So you are given the matrix A equals that and matrix B equals that, which are two matrices. Find the product AB and BA. So our AB just means to multiply A by B, and recall that we multiply row 1 by column 1, that is row 1 for matrix 1 by column 1 for matrix 2. And when you do this multiplication, we obtain the identity matrix. Now for BA, when you equally do the multiplication for BA, we obtain the identity matrix as well, 1, 0, 0, 0, 1, 0, 0, 0, 1. And the relationship between the two matrices, because that's what has been asked in the question, is these matrices are inverses. A is the inverse of B and B is equal to the inverse of A. That's what has been shown here clearly. Then now they say find also the matrix Bm, where m is minus 8, minus 7, minus 1. So we just have to multiply. We pre-multiply m by b. So b times m gives us the matrix minus 4, minus 1, 5. So the next part of the equation now says that we should solve the equation. Hence, whenever you have a hence in equation, it means that using your last answer, continue with that answer to obtain the solution for this part. If hence is written and use another method, you are automatically gone out of the rules and you should be graded 0. But if they say hence or otherwise, it means you are at liberty, you can use another method. Here the hence does not give us an option to use another method. So hence, we must continue with the previous answer. So hence, if I express this equation in matrix form, I will have 1 minus 1, 1, 0, 2, minus 1, 2, 3, 0. Where this matrix is a coefficient matrix of the x, y, and z values. It is a coefficient matrix, and I'm solving for x, y, and z should be equal to the constant matrix minus, that's 8, minus 7, and 1. So this is my A. If you look very well, it's that this matrix corresponds to the A. That's the coefficient matrix, the same as the A that was given in the equation. And we have x, y, z to be giving us m. Now, for us to solve for m, according to metric simplification, you know that ax is equal to m. We post multiply both sides by A inverse. We will have A inverse times ax is equal to A inverse times m. But we know that the inverse of matrix A is B. So I can replace A inverse by B. Ax is equal to Bm. And BA will give me the identity matrix. And any matrix times the identity matrix leaves the matrix unchanged. So my x will just be equal to Bm. And I have already looked for Bm in this question. Now Bm here is minus 4, minus 1, 5. So I'll just replace this by the values. And my x, y, z is equal to minus 4, minus 1, 5. So x is minus 4, y is minus 1 and m, and z is 5. So that brings us to the end of this paper. Recall that we already published the first part of the equation and many other things will be coming your way. Stay tuned and don't forget to subscribe so that in case we post anything, you'll be the first person to be aware of. And in case of any other query, you can equally get to us. Stay tuned, subscribe, like, share. Bye bye and good luck.